All right, good evening. This is Adam Buckner, one of the online trainers here at Unity. Today's session is on 2D scrolling backgrounds. Now, this is not specifically 2D. We can use these for 2.5D games as well. This is basically how to scroll flat background art as opposed to, how to move 3D objects in the game. So what are we going to do today? We're going to look at some different ways of scrolling some backgrounds. And we're going to talk about 2 or 3 different ways of doing it. And for these type of shooters, these shmups for, scrolling backgrounds, you can actually move the game object over a map. And there are some advantages of doing that. It's a very Unity-like and editor-friendly workflow. You can preset your enemies, you can create terrain, you can have 2D or 3D objects, and you can preset them, and you can activate and deactivate these enemies with a sweeper object that moves with your character, and we will do a session on this. What are the disadvantages? Bigger setups, potentially more resources. And they're really completely two different styles to approach a game. So just because I'm approaching right now a game with doing scrolling 2D backgrounds, that doesn't mean that you could have a static background that you could move your player character over. It's just a different way of approaching a game. There's going to be 3 different ways we're going to be looking at backgrounds. One is physically moving a quad, a tiled object. The other is offsetting the material's image on that object and not moving the object at all. And a third one is sort of a hybrid of both approaches. And we're going to need some assets. And so speaking of the asset store, the first place we're going to go is the asset store. Hey, Command 9. So that's in Window, Asset Store, Command or Control 9. Bring up the asset store. We're going to be a little bit slow today because I'm got Twitch in and out. So bear with us. And then I'm going to look for Space Shooter because there's a scrolling background that we have in there. It's going to be our starting place. The Space Shooter assets, they're part of the Space Shooter project tutorial that you can find on the Learn section under Projects. And there it is, the Space Shooter. So I'm going to import these assets. We're only going to be using a very small amount of it. Also, what I'm going to be doing is using the player who's already pre-built. That'll give us a leg up on testing our on the stuff that we're showing today. So this is how we import objects from the asset store. You open up the asset store, you find the asset that you want, and you can simply import them directly into the editor. And I'm going to just suck it all in. I could choose to check off the items I want at this stage, but I'm just going to import it all and then deal with it in the editor. Now, Twitch is a bit laggy. I'm reading the chat, and so if the video is not updating, then please re-roll the page. The video should be changing. I've got full bandwidth here. We have imported all of these assets from Space Shooter. I'm primarily interested in the done material because I want the done scene, and then I also want the background. So I'm going to create a new folder, and we can do that by going to Create Folder, and it's just going to make this up. What other stuff? Just other stuff. And I'm going to put all of my other stuff in there. I just would like to have the done main, which I'm going to load. I'm going to load it this way. So this is the done main. This is the Space Shooter tutorial project, which you can get, and you can follow along on our website. I'm going to do a save as on this, and I'm going to save this in my assets in a new folder. I'm going to call this _scenes so it sorts to the top. And I'm going to call this one just our example scene. So this is our example scene for today. So this, I've now saved this here in the _scenes in the example scene. We can see that up here in the header as well. So I'm going to dump models, materials, done, audio, all of the stuff. It's just going to go into other stuff for now. We'll dig out what we need. And then in our scene, I'm also going to create another game object, and I'm going to call this one other stuff as well, just other stuff. And I'm going to put in the star field, display text boundary, things that we don't really need for today's game controller, stuff that we're not going to need for today's example. And then I'm just going to turn all that off. Boink. So this is just setup. So we've got our player. Let's go ahead and just get rid of the done part, just to give us something. This is just so that we've got something to fly around. I'm going to keep the lighting. I'm going to keep that main camera, and most importantly, I'm going to keep the background. So let's import the other assets that we're looking at, just while we're getting our assets together. On my desktop, I have two other sets of assets, a background, which we've got front, back, and middle, which we can see when it goes when we get it into the game. And then also I have something that we're going to do for the third section there called strip tile background. So I'm just going to grab these folders and then drop them in. So we now have all of our assets together. There's our artwork for our background. There's our, as I said, the artwork for our background. And let's take a look at this, the way that this plays right now. So right now we've got a very slowly scrolling background, and this is what we're going to be looking at how to do. If we go ahead and look at the scene view, this is actually two quads with the background attached that's slowly tiling throughout the game. And then when it reaches a full cycle, it then resets itself and it goes through it again. This is being controlled by this script done background scroller. So let's go ahead and open this in MonoDevelop. So this is a very simple script. So our background scroller takes in a scroll speed as a float, and it takes in our tile size. So we need to know what the size is of our tile, and then we've got a private vector3, which is our starting position. And then when we start the game, we grab that start position as our transform position, so the transform position of the quad. And then in update, every frame, we are using something called mathf repeat. Now, if we don't know about mathf is very useful. The quick shortcut key I'm about to use now is Command on the Mac or Control on Windows, and the single quote key. And of course, it opens it up in another window. Come over here, please. So let's get that going. So that's our documentation. So if you do Command or Control and single quote, that'll go straight to the documentation on the thing that you have selected. This is mathf, and what we're going to be using is mathf repeat. And mathf repeat is a lot like, if you know what this is, the modulo operator, but it returns a floating point number. And essentially it means that you can give it a value, which in this case is the float, which we have for t. Let's see if we can pump that up for you guys as well. There we go. So it's no larger than length and never smaller than 0. So we can use this to take our tile and move it for the length of the tile. And when the tile is when it exceeds the length of the tile, we can pop it back to the beginning. And so what we're using for that is the time in the game. So we have a new position, which is just a float for moving forward, and we're using mathf repeat, and we're taking the time in the game, time.time, times the scroll speed that we assign, public value, and then we give it the length of the tile, and we say never exceed the length of that tile, and it will go back and it will repeat. And then we take that new position, and we take our start position, and I'll show you this in the game, how that start position, and then we add to it vector3 forward times that new position value. So let's take a look at that in Unity. So then what we do is we have our background, and there's actually two tiles if we look at it. So there's one tile here, and there is a second tile attached to it. And the reason that we have that second tile attached to it is that, let's see if we can bring the game out here, just so we can see it for a little bit. 2x3. Is that if we only had one tile, and then we start to scroll that tile, not the dead one, there we go, that one, we'll see a blank spot. Because the tile itself will fill our screen once, and so as it moves down, we need something else to take up that spot. And so that's why we need to have two tiles, so that when it's scrolling, we've got two tiles worth, and it will come down one entire width, and then it will pop back up again. So very simple code. So again, we can see that in motion. And then let's go ahead and speed this up. Where's our scroll speed? So we can then make our scroll speed bigger. Let's make that even bigger. And we can see if we look on the left-hand side, -10 even, nice and fast. We can see how that mathf repeat is repeating that motion. So we take the length, it moves at one length of the tile, and as soon as it reaches that one length of the tile, it then goes back and lays down the second one. Now, this is interesting, it's useful, it works, but there could be an easier way of doing this. And there is a really nice link to a Unity tutorial that is from Japan. And let me get the main one. This is from Unity Japan, and it has been translated. Yes, thank you very much. So you don't have to dig through the Japanese version of it. We've translated it into English. There's the link to that, and it's a full 2D scrolling shmup shooter project, which I've stolen some of the artwork for. And so that's definitely worth looking through if you want to go ahead and see all that all the way through. But what we're going to be looking at today is the background. And so I'm stealing this background art, and I'm stealing very similar code to the stuff that they're doing. I'm doing some things that are slightly more advantageous to us than they've done in this. But let's go ahead and show. I'm going to set this one up from the ground up because I find this a much more interesting approach than actually physically moving the tiles in the scene. But I just wanted you to know those links so that you can follow that through on your own. So let's go ahead and set up. Let's turn off this background. I'm going to make a parent game object just called backgrounds. And then I'm going to put our current background in it and turn it off. Boop. And then I'm going to create a new parent game object. And I'm going to call this parent game object our offset background. And this is a completely different approach to how you would want to scroll a static background. So I'm going to put this in our backgrounds as well, and then make sure, oh bother, I didn't do that first. Let's pull these guys out. And what I want to do is make sure that our backgrounds is set to 0. So I'm going to reset the transform. And then I'm going to put these background guys back in, and then our new offset background parent, and reset that background as well. So now I've got this is just a placeholder. It's an empty game object so that we can organize all of our different backgrounds. The basis of our background is going to be a quad. That's going to hold our image. So let's frame select it on that. It's going to be oriented the wrong way for this particular game because this particular game is top down. So again, I'm going to reset the position, and then I'm going to rotate it 90 degrees on the X. And then let's just pull it down so it's down below our 2.5D, our 3D spaceship. Let's just, how far down do we want to go? Let's put that in global. So I'm moving it into global space. So let's push that down maybe -5. And then 0 that out. So now we've got our quad. Let's move this out of the way. And let's attach our image to it. So let's go ahead and grab that background back, which is this is going to be slightly different. If you guys go to that Japanese tutorial website from Unity Japan, you're going to find one that is 4x3 for a wide, it's probably a phone of some sort, I think is the setup. Whereas I've made this square. I've taken it into Photoshop and made this a square texture. So it's going to be slightly different. And remember, we want to get it on the quad. I can just simply drag it onto the quad. It's going to make the material for me. So there's my material. And we have now attached that to the quad. So let's go ahead and make this our background. And put that into our offset background parent. Just so that we have some organization going on. If we look at this, it's awfully small. It's 1 unit wide, and that 1 unit by 1 unit is going to help us going forward. So let's stretch this out. I'm going to bring back the game, which I've got to set to 2x3. And let's bring this out to, I don't know, say 30x30. And I think I want to set the aspect ratio here to upright. I'm going to make this to a 900x600 game, just so that I've limited, so I've got a set resolution there. Which is the resolution of the original space shooter that we're using. So I now have this set to 30x30, but that's awfully big. But if I've got a square image. If I'm down to 15x15, we can see that that image here. Not only is it dark, but it's not filling the screen. So I don't want to distort it, but I'm having trouble here. If I'm big, it's too big. If it's small, it doesn't fill the screen, or it's distorted. the solution to all of these problems is in our material. So if we look at the material right now is diffuse, so it's going to need a light on it. It won't be lit up without a light. So I want to use an unlit shader and make that an unlit texture. And now we've got that lit up. It's a relatively dark background just because of the nature of this particular game. The other thing that we're going to be looking at is the base RGB and its tiling and offset. And this is going to be the fundamental power behind what we're going to do for moving this background. First thing we want to do is we want to tile it by 2. So now I've got in that 1 by 1 quad, let me bring that out. I have tiled it 2 by 2. I would like to have my my ship over sort of the center of it rather than the edges. So I'm going to offset the X by half. So now I have my ship here over the center of that, that image, and it's hanging off the edge of that quad here with half of it here, full down the middle, and the other half on the other side. Because I've offset it by a matter of 1/2 of the width of this texture. So now we have this set up. So we've got our unlit texture, we have our offset, but what this is going to show us is how we can start to move the tile. So if we look at the X value, if we start to move it, we can see that as I increase that value, it's moving down. So I can take a script, and the script can reference the material itself and change this offset value. So let's go ahead and write a script to do this. So let's go ahead and add a component. Let's add a new script. Let's clear that out, whatever we were searching for. Let's add a new script. And let's call this something like offset scroller. So let's call this offset scroller. C#, that's dumped our... Here, I'm just going to put that, let's create a new scenes folder. So let's, not scenes folder, a new scripts folder. So let's create a new scripts folder and call this scripts. And then drag that offset scroller into scripts. And then double click it and we'll load that into MonoDevelop. So now with this in MonoDevelop, what do we want to do? Well, we're going to need some values. The first thing we're going to need is a public float. Only if I can spell. And that public float is going to be our scroll speed, because we have to have some control over how fast this scrolls, and so that will be public. And then in the meat of the this script is going to be update. And we're going to use that same mathf repeat, because we want to repeat the movement, but we're not going to move the tile itself. We're going to move the image on the tile. And so again, what are we going to use as a way of controlling how much that tile moves? Well, we can use time.time, because time is always going to move up in the game. So if we use time.time, we can pull something that is regular, and then but yet advancing. So we can send that to mathf repeat and have some control over it. And the control will be our scroll speed. There we go, scroll speed. And what's our maximum is 1, is simply 1, because we've got, when we're tiling, when we're looking at our offset, we're looking at our background, we're looking at the material. This, notice as I go to 1, no change in the background. If I go to 2, no change in the background. Because that offset, if I offset it by a whole integer, it's going to simply stay in that same point, because it's offset by one whole value. Now, we're going to assign this to a temporary float. So let's make a float called y. It's going to be equal to mathf repeat time.time times scroll speed with a max of 1. So as we go through, it's going to count up from 0 to 1, 0 to 1, 0 to 1. So then what we want to do is create a new vector 2, which is going to be our offset. And that's going to be equal to a new vector 2, because we can't assign this value directly. And that new vector 2 is going to be equal to 0, because we don't want to change the x, and our new y value that we've created just in the line before. And where we grab this is we grab it with our renderer, and we ask for the shared material on the renderer. And all of this you can get in the documentation if any of this is particularly confusing, or we can talk about it in Q&A. And then we want to set the texture offset, which is that value that we're trying to change, on the main texture, which is called main text. And the value is offset. That's all we need. So we save that, come back to Unity, and trust the gods that I don't have a compiler error. And I don't. Yes! Awesome. So scroll speed. Let's something small, 0.1, so it'll count up over a second. And let's hit save, and let's hit play. And now we have a scrolling background. And that's scrolling on the tile itself. So when you look over here to the left, we can see that it's offset going down on the left, and we can see that our ship is going through it on the right. So we can, if we wanted to, we could, zoom around. But we have a problem, which is we've lost our offset over here. We've set that up being something very nice. We don't want to change that value. And the other thing that we notice is that when we stop, we see that this is 0 and this is some wonky number. Because we're updating the asset, I mean, it's annoying. We're updating the asset, and the asset's saving this value. So how do we get it so that we can maintain the value we've put in without having to put it into our script? And how can we reset the background to where we started from? Well, to do that, first of all, oops, come back here, mister. Let's set it up to the way we would like it. So 0.5, please, and 0. So that's our good starting point. And in our script, let's, hey, that's not monodevelop. Come back here, Mr. Monodevelop. We want a private value, private variable. And it's going to be a vector2, and it's going to be saved offset. And in start, we want to say our saved offset is going to be equal to, you got it, our renderer dot shared material dot get texture offset. And then that texture offset will be on our main text. So we grab that and put it into our saved offset. And then what we want down here isn't 0, because you see we were setting that x value to 0. We want this to be our saved offset x. And when we do it this way, when we have a private local variable and we set it at start, we can then set up that that image in the editor any way we want to, and then we just need to remember to set it back to that saved offset. So we want to say is on disable. So when we disable this script, we want to say our renderer dot shared material dot set texture offset is the main text, which is that we have to tell it where it's going to go, which is that main text. And what are we setting it to? Our saved offset. So now, when we hit play, background scrolls. And we can see those values are changing. We're still at 0.5, which is what we set it to. But when we hit stop, that goes back to 0. So are we clear with what we're doing at this point? Because if we are, then we will go back and we'll take a look at this and take this one step further. How come I'm not using getGameObject? The reason I'm not using getGameObject is that these are all components on this particular game object. So when I'm asking for the renderer, I don't need the game object because I already have it. I know who I am. I know my own game object. So what I'm asking for with that script is this script is asking for this renderer, the mesh renderer up here. If I needed to get the renderer on another game object, I would need to have a reference to the game object to find the renderer, or a reference to that renderer directly. Now that we have this set up, let's do some parallax. So basically, parallax is just setting objects to move at a different speed. So we've got our background here, and that's our background object. So let's create another object. Let's just duplicate this. Come on, you can do it. Duplicate. Let's call this midground. So that's our midground object. And for our midground object, let's bring this up a little bit from -1 to -4, so it's above itself. And then we can simply grab that middle bunk, and we've now replaced it. Now this is going to look a bit ugly, and I'll show you why in a second. Let me bring this back to scene view. What the heck is that, you ask? Well, the bottom layer was solid, and so we used that as an unlit texture. This is a semi-transparent texture, so we need to go to unlit transparent. Boop. And so now we have a sort of catwalk with little light beams on it. When we come back and look at the game, I will turn this off, and you'll see what I mean. So it's a little catwalk with lights shining down on it. But again, it has that same problem with tiling. So let's tile that twice. And then let's offset it a little bit, again, by about 0.5. But I sort of felt that it needed to be about 0.55, sort of moving it over a little bit. Now, if we were to save this and hit play, then it doesn't make a difference because they're both moving at the same speed. So let's now markedly slow down that background, because one of the things about it, to give it scale moves as far, large things far away move very slowly. So let's make that scroll speed, 0.025. So a very slow scroll speed on the background. And let's give the midground a faster scroll speed, make 0.075. Now that we have two different speeds, we hit save and we hit play. And now does this start to look like a parallax scroller? So for a third level, let's duplicate this again. Let's call this foreground. Oops, come on, foreground. And drag on our foreground object, our front. Boom. And so again, in each time it's automatically made the material for us. And again, we need to make sure that it's unlit transparent. And then let's double up that tiling. Let's do a tile of 2 to 2. And then offset, again, about 0.5. But it's a little bit ugly where it is. So I was sort of found it was a little bit nicer, 445. And then let's pop that up one layer physically in space above it. Now we could also use sorting layers and order in layer to be able to change the layers that we want, but we're not going to do that. Oops, I went the wrong way. Make that a 3. I'm just going to simply use the transform position at this point for this. And let's change the speed, the scroll speed there as well, to 0.1. Save and play. And so now we've got a parallax shooter. We've got that super slow moving background really far away. We've got and 2 layers on top. Oops, come on over the game. And we can, don't have anything to play against at this point, but there you go. Super scrolling background, parallax background. Simply by offsetting the material. So when I was doing my research, I encountered something that I thought was rather interesting, which was that when looking at top-down scrolling shooters, I used to play Xevious very, very badly, and I'm not sure the age of our our audience today, but playing Xevious was something that I was really, really bad at, but I really enjoyed playing. And so I did some research and how did they make it? And one of the ways that they optimized the backgrounds is all of the background map was on one giant square tile. And when you play, you go up a sort of a column, and when you reach the top of the square, it tiles with an offset column. It's basically offset by 1/4 or 1/5 of the square. And so they reuse this entire square texture for a long, thin game. And I thought that it would be kind of fun to see if we could do the same sort of thing. Well, I don't have a Xevious background. I'm going to go ahead and turn off our offset background that we have here. But I do have a map of Washington State. Why do I have a map of Washington State? Well, I'm from Washington. I'm from Seattle, actually, even though I'm living in London. And Unite is going to be in Seattle in just a few weeks. So I thought it would be kind of an appropriate way of showing off this idea. And this isn't quite what it seems. And it is just a grab from Google Maps. I don't have permission to use this in a commercial game. This is for demonstration purposes only. But what I've done is I have made sure that all of the edges tile, but they don't tile top to bottom. They tile top to bottom and offset by 25%. So let's go ahead and set this up and see how this works inside the game. So again, let's create another holding parent and reset this holding parent to 0. And let's call this holding parent stripped background. And that stripped background is going to go into our backgrounds. And then I'm going to create a new, new quad, not a new game object. I'm going to create a new quad. Yay. And this quad, again, is going to be called background because I can't think of anything better to call it. And that background is going to also be reset and go into our stripped background. And then we're going to use our strip tiled background as our texture, and we're going to use unlit texture for that texture. Let's go ahead and zip that in, and we need to make sure that that is again rotated 90 degrees, so we're facing down, and then let's set that to -5 again. So now the setup on this is going to be a bit funny. I'm going to get rid of my perspective camera so it's there. I'm going to stretch it out. I'm going to stretch it out even wider than I did before. I'm going to stretch this one out to probably 60 by 60 might be big enough because we were doing 30 by 30 before. So let's do 60 by 60 on this one. So it's twice as big. So let's scale that background up to 60 by 60. Really huge. Let me just straighten out our view. And then I want to, looking at the game, kind of here, not big enough screen to do everything we want to do. I want to offset it so that we start in the lower corner, down here near Aberdeen. If anyone knew of Nirvana, that Grays Harbor down there in that area as well, that's where that came from. So I had some magic numbers for that, which was about 25 down, just because I worked this out. It was nice and easy. 25 down, and we're going to go over about 22.5. So we start there, down there near Aberdeen. I need 2 tiles. This is going to be a mixture of the 2 approaches that we had, the original background and the background that we did with the UVs, because we can't simply slip the UVs on this. So I'm going to do a hybrid where I'm going to be using 2 of these. So I'm going to duplicate this, and I'm going to parent one inside the other, and then I'm going to offset it by -0.25. And then lift it up, oops, come back here. And 1, I believe. And up you come. Is that 1? Yeah, it'll be 1, 0. So now you can see that they're offset by 1/4, 1 column. And what I've done is make sure that this line matches up, even though we have moved that aside by 25%. So we're going to need a new script, and it's going to be a concatenation of the 2 that we've already done. So on the parent, let's go ahead and create a new script. And then let's call this new script what should we call it? Strip scroller. How about strip scroller? Strip scroller. So again, we've got our strip scroller. Let's put that into our scripts folder and then open that up in MonoDevelop. So we've got strip scroller here. And the first thing I want to do is copy and paste all of the stuff from that done background scroller. So I'm going to grab all this content from the done background scroller and just paste that into strip scroller. So, whoops, I didn't get it all, did I? Nope, missed that last line. So again, what we have here is we've got the scroll speed, the size of the tile, and our start position, and we're going to move that tile one tile's height each time. And then in our offset scroller, we have all of the information about how to move and offset that texture on the quad. So I'm going to grab the saved offset. Actually, let's put down there with the privates. And then I'm also going to grab the setting the saved offset that we do in start. And I want to make sure that I have the vector 2 where we set that. And notice I'm not taking our float Y and mathf repeat at this point. I'm going to take all of the sort of boilerplate text because this is the only way we can do this and get done within our hour. So I'm going to have the point where we set the value, and then I'm going to grab our on disable. So there's our on disable, and we also need the end of our update. So essentially, I've taken and sort of mashed together the chassis of our two scripts, the one scrolling and the one offsetting. So that's the chassis, the basis of what we had in our previous scripts. But what we want to do is talk about replacing this line, the mathf repeat line. This one gets a little bit complicated. Not much, but a little bit. Which is what we're trying to do is when the tiles do one complete loop, we would then want to offset the texture by 25%. In that mathf repeat, so when it goes through 4 of them, it comes back to where we started from. So let's start off with our float. We are our float, but this is not going to be Y. We'll have to change that in the next line anyway, but float X. It's going to be equal to our mathf repeat. And what is the repeat going to be? Well, the beginning is going to be the same. It's going to be our time.time. And it's going to be times our scroll speed. And we want to have our tile Z, our tile size Z again. So we want to know how big that tile is, but we also want to have it times 4. Because we want to repeat this 4 times before we go back to 0. So we're going to go through this 4 times before we go back to 0. Now this can all be written in one long line, which is probably technically a better way of doing it. But I felt that one long line is going to be a little bit hard to sort out and a little bit hard to see. So I'm going to now break these down into little bits so you can see what we have. So we're going to do a lot of these x equal x things, which is not really the best way to write code. But we're going to then divide the value that we get by our tile size. Because what we're trying to break this down is into a simple single value that represents each pass, and each pass being a quarter of the value. So because remember our offset, if we offset by 1, we've gone through an entire loop. We want to offset it by 0.25 every time we pass through this cycle. And so then we want to take that and we want to take the floor. We don't want to round it in the middle. We want to take the floor. And the floor is basically rounding to the lowest possible value until you get a new integer. So that's mathf.floor. Oops, learn how to spell. Of x. So we're simply taking the floor of it, and then we want to divide it by 4. So we get 0.25 for every pass. Now, let's save this, come back to Unity, and pray to the gods, the compile gods. Nope. I forgot to set it. I forgot to change this one. I knew I would, I knew even after saying that I would do that. And so we need to reverse these two, which is basically we need to have assign x and use our saved offset y. Because we don't want to scroll the y. The y is scrolling because of the, we're physically offsetting the transform, and we want to change the x value on the offset. Now, let's do maximize on play. Oh no, we need to assign our scroll value. Trying to get done. Rush into that finish line. Scroll speed. Our scroll speed is, I don't know, 0.25? Something like that. Let's just see. And tile size Z is 60. Now let's see if I've dropped something because I'm trying to get finished. Oh, we're going backwards. That's the other change. We want to go back. There we go. Now let's speed this up a bunch. Not 0.25. Let's make this 5. So now, if anyone knows anything about the geography of the Northwest, they know that when you go up past Vancouver, which you can kind of see on the right, that you don't come to Olympia, Tacoma, and then Seattle. We must have done an error because that should not have happened. This should have been continuously scrolling. Let me quickly check to see what I've done because that should. Let's look at this not in maximize on play. It was a bit gutsy of me, wasn't it? What have I done? So that has come up. It didn't look like we were resetting properly. Let's take a look at our offset value. Now we should. We're not offsetting because that should then offset to 0.25. So what have I done wrong? Wrong method. So I want to have that from float. That's what I get for Russian. Boom. Boom. Doing there. So let's save this. Now let's try that. There we go. Whew. Russian. It's copying and pasting code because I'm supposed to be trying to keep these under an hour and we're at 56 minutes in and I want to get some Q&A done. So yeah, sorry, that was a bit of a rush. But if you take a look at this, we're now continually scrolling through this single image. And you also can't do this with sprites because sprites, you can't offset the material. So this has to be done with a quad and standard material. You could write code for looking at a sprite atlas and moving things around, but I thought this was rather clever, so that you can have this continuously moving through a single. You have a single image. You have all of your 2D map or all of your 2D environment on a single image. As a matter of fact, if I remember correctly, they also saved some value in Xevious, but you could see 20% of the next strip on the edges. They overlapped. But because the context was so different that nobody noticed. And so you could use, you could do this, if you take out the city names, you could do this in 5 or 6 strips and overlap what's happening on the edges, and you won't necessarily tell your audience the fact that you're simply scrolling around on a square. That's it for the class. Follow us. If you have any questions, go ahead and follow us on Twitter at Unity3D, at Mike Geig, at Will Goldstone, and me, Adam Buckner, at the Ant Ranch. And we're perfectly happy to answer tweets. You can post on the teaching section in the forum. You'll see in the stickies there is a thread on live training. If you have any questions, comments, criticisms, requests, go ahead and post them there, or you can also do that here with us on Twitter. And I'll stick around for a little while, and I'll answer your questions either about this session, about any other session, whatever you'd like. Sort of an ask me anything, but be perfectly honest. I know some things, I know many things, I don't know everything. Yes, it is possible to use quads in normal 2D mode. There's no reason that you have to completely divorce yourself from 2D and 3D. You can use quads in 2D mode. You can use sprites in 3D mode. The only thing that is really incompatible are the two physics systems. So if you drop a cube onto a sprite with a circle collider, they will not interact. They will not collide. So physics 2D and physics 3D will not interact with each other. They're two completely different systems. Now roll 22. Are any of these methods resolution safe? In other words, if you change the resolution of these, if you change the resolution that these are played in, would the background still display correctly? It depends how you set up your game. As long as the camera's relationship to the background stays the same or similar, the resolution will stay the same. Can we have a quick look at the code, please? Yes, you may. Let me just bring that down one stop so you guys can see it all the way. Adam, let's say that there's a ship in space. Would it be a bad idea to use a particle system to emit stars instead of using parallax with images of stars? No, as a matter of fact, it's not. As a matter of fact, it's not to the point where that's what we do in this in the original version of this. Unless I've broken something, this should be able to work. Let me show you by going to the other stuff where we put it into the done main. Now this is the done main here, and if we hit play, the stars in the background are emissions. I'm just going to blow up. So you can see that there's stars moving in the background here, both foreground and background. And if we're to look at that in the scene, they're here under star field. And that's just a simply apparent holder object that's putting the star field below the player object. Let me just put these together. Move you guys away. So there's our particle system. And we can see that those are emitting two selections of stars there. Let's go back into perspective so we can see that properly. So that is just simply a particle system. And when we do that at play, at runtime, we get slightly scrolling background and the particle system, and it gives us a nice bit of feeling of movement. Adam, would it work well to use layers from 2D mode in order to simulate depth when using an orthogonal camera and using parallax on them like you did here, but using sprites instead? Yes, you could, with one exception. Currently, you can't offset that main texture in a sprite. That's something that sprites don't do. That's something that regular texture 2Ds can do. So yes, all of the sorting we could be doing in sorting layers. We could have left all of those backgrounds on one layer, and then in code used used sorting layers and order in layer to be able to sort them. But you'd need to find a different way to scroll it, probably by physically moving the sprite, doing the looping technique that we have on this particular background, because you can't change the texture offset on the material with a sprite. Am I right in thinking that rigid body center of mass is not available in the current release? A rigid body 2D center of mass. Let me read that again. Am I right in thinking that rigid body 2D center of mass is not available in the current release? I don't know. I know that rigid body 2D center of mass is on the books, but I'm not sure whether it's in 4.5. Oh, on the other hand, how's that? How about them apples? Rigid body center of mass. Why is it not working with delta time? Oh, that's because delta time is rather interesting. Let me just do one thing while we're here. Let's either find an existing script or make a new one. Let's just make a new one, just get easier. Create a C# script called time tester. Oops, let's not make it in all capitals. Time tester. So time tester. let's just put this on an empty game object. Time tester is going to do two things. It's going to debug log time.time. And it's going to debug log time.delta time. And I'm going to be proper about this. Time and delta time. So let's put this on a script. In every frame, we're going to see what happens with time and what happens with delta time. So let's grab that and put that on the main camera. Come on, you can do it. And then bring up our console. And collapse. It's not collapsing well. Collapse, thank you. That's enough. So if we look down this, we can see that time is 0 and delta time is 0.02. Then time is 0.02 and time. So we can see that, but look at delta time, 0.1, 0.02, 0.04, 0.03, but time continues to count up continuously. Delta time is purely the time it took to render the last frame. And so it will always be a very small number. It will, depending on how fast you're rendering. I mean, obviously, if you've got a very slow frame rate, then the number will be larger, but it will always be a small number. Whereas time, we get 10 minutes into the game, it's going to continue to grow. So this is why we need to use time for the scripts that we are using, not time.delta time, because this is a number that's going to continue to increase throughout the game. And it's going to be regular based on how our game is playing. If we made that delta time, nothing would happen very well. Delta time. And so remember, we had a perfectly normal scrolling background. Is this going to let me do it? No. What have I done wrong? Oh, spelt it wrong. Ha! Thank you very much. Now let's watch our background. Oh, it's jiggling around and not moving very far. So it is, if we're looking very closely at our background, if I can snatch it, come on. There. Oh. We can see that our Z is moving a tiny bit, but not very much. So every frame, it's sort of jiggling around. But it's not enough to actually move anywhere because time.delta time is sort of a continuously small number. Cool. All right. Well, thanks for coming. You can follow us, please. Follow us at Unity 3D. Follow us at Mike Geig. Follow us at Will Goldstone. And you can follow me at The Ant Ranch. You can also leave messages for us on the forum in the teaching section under live training. And you can give us comments, questions, suggestions, and let us know what you think.